Hello everyone. In this learning session, we're going to be talking about terrestrial laser scans and how they come into Revizto. Now, if you were part of our earlier learning session with the drone flights, you'll notice that a lot of this is about getting the information into the correct file format. And not a lot changes here on this front. We're going to be using some of the major tools in the industry for terrestrial scans, getting those into one of these file formats you see in this list here, and then getting them into the tool. Now, we're going to start way back at the beginning of how these scans are created. One of the things we're going to be looking at here is ReCap and the coordinate systems that ReCap uses. Keep in mind in Revizto, we natively import this data at its coordinate system specified here, but you will have the opportunity to transform that inside of our tool. So if it doesn't come in exactly where it needs to go, or there are no coordinates associated with it, we will be able to change that once we get it into Revizto. However, having the right coordinate system with the underlying data is always the best practice. In here, you'll see that I'm searching for various coordinate systems that are predefined inside of ReCap, including all of your common UTM and NDA 20 or NAD 27 type coordinate systems, along with everything else. And just really taking a quick look at how we search through those and specify those, as well as the units and all of that that goes into how these scans are positioned inside of ReCap and then in turn imported into Revizto using the RCP or the RCS file format. See here, we'll search for the NAD 27 and we can actually see them all populate here. Now, when I say OK, that's where we can go in here and we're going to take a look at the ability to save this as an RCP. Now we can use the RCP file format directly, or we can use RCSs. And I'm going to briefly show how RCSs could come into play by creating some regions in the project. What I'm going to do now is I'm going to actually divide this scan up into two regions and then show how we can export those as each region. The reason that this is important is because we can potentially take one scan all registered and indexed in one software, and create multiple exports for Revizto so that we can easily toggle on and off the various files if we need to see one section of the building and not another section. I've made some selections here, and as you can see, I've created regions 1 and regions 2, and you can see those highlighted as I select between these two. Very easy, create a selection, create a region. Now, here what we're going to look at is the ability to export to various file formats. You'll notice that we have E57, PTS, RCS, and RCP. In Revizto, we can use either the RCP or the RCS format. So regardless if it goes out to RCP or RCS, we'll be able to bring those in the same manner. Once I choose export, it will actually generate those files for me. And then we can begin to go into Revizto and grab these files and bring them in. Once inside of Revizto, what I'm going to do is I'm going to go up to the project panel and select new. In this situation, I'm creating a new project to house my point clouds. Now, this can work with a new project, or it'll work the exact same way with an existing project as well. Once the project is open, I'm going to select the import key from the project pull down, and I'm going to go out and find the files that I wish to import here. Now, if you were part of the drone learning session or have seen the drone learning session, you'll see where these meshes come into play, and there can also be some valuable mesh workflows inside of terrestrial scanning. But today we're going to focus solely on the point cloud file formats that were brought up at the beginning of the learning session. Now I'm going to jump in here and go all the way to my RCP file. As you can see, the RCP is stored along with the support folder here, making sure that all those files are accessible when we go to import this. As you can see, I can choose the units as well as the quality, which represents a decimation. Here we can see that we break it up into 5 qualities, And there we have a decimation value on a grid. So highest quality is 0.01 foot decimation grid. And then once all those settings are created, we can go ahead and import this. Now I'm going to speed up the video a little bit here as we import through this. This is not the actual time that it takes to import these files. It depends on how large the file is and how powerful of a PC that you're working on at that time. But once imported, we can see that here's the point cloud brought in on a high quality export setting. And we can see that now we can simply pan, zoom around like we normally would with any of these model elements. We can select the scan, and we can actually see the scan in the object tree. So we're going to dive into the point cloud a little bit and highlight some of the features that have been brought here in Revizto 5 that go above and beyond what our capabilities were for Revizto 4. Here you can see we pull our measurement tool. We can specifically grab onto point cloud objects and measure those. As you can see here, we're going to jump over here and actually measure this conduit. And there you can see we get a precise dimension based on the point cloud elements. Here what I'm doing is I'm using our section cut tool to cleanly cut a section inside of the point cloud. As you can see, we've done a lot of work making our planes and our boxes work, cutting those sections very clean along the point cloud elements. And all of our normal tools will work with these point clouds as far as sectioning goes. The collision of the point cloud makes for another interesting topic, which is the ability to actually place issues on existing conditions. This is very important for anyone doing inspection work or working inside of an existing facility that may have parts that are continually operating, tag out procedures. All these various things that can alert people to hazards, health and safety, as well as coordination and design review aspects. Here we can identify a hazard on this piece of equipment simply by grabbing that stamp and placing it right on the object. And there we can go and grab another one and drop that there as well. Here we can also link and unlink the point clouds. This is really great going back to that RCS workflow because now we can section off a very large point cloud and only show parts of it that are relevant to what we're doing and hide the parts that are not relevant. Very important for field and iPad workflows on lower end devices because those may not have the power to show the entire point cloud, but by loading and unloading these, we can actually visualize a large project in a single environment by toggling on and off the various aspects. We can also control our point size in Revizto. If we want to change the decimation, we'll have to re-import, but as far as visibly changing the point size, we can do that directly in Revizto so that we can create a nice smooth appearance of that point cloud information, even if it's not the most densest point cloud information that we could potentially create. Another aspect to point clouds, and this could definitely come up, is the ability to Another item that's very important to point clouds is the ability to reposition them. In here, we can go into the scene transform, select that, and now we can actually begin to input various offsets of the base coordinate that will allow us to change the positioning of our point cloud in the project, allowing it to align with other aspects. Once again, it's always best to have these coordinates set up from the beginning to fall into the right spot, but that's not always possible given the various amount of workflows that we see in Revizto. So if that point cloud needs to move, we do provide that capability to move the point cloud into position with any other models. Some of the other things that are really helpful, going back to the measurement tool, is the ability to use our spot elevation to reveal X, Y, and Z coordinates, as well as elevations of certain points on the point cloud itself. As you can see down below, I can verify a coordinate right from here. So thank you for joining our learning session. I've put the file formats that we work with back up on the screen for anyone that needs to see that, and thank you very much.